Hi there, my name is Eric and this is a presentation on focal length and perspective. What do we notice about focal lengths? Well, when we use our cameras we tend to pay attention to our subject, but not so much the background. As a result, we understand that zooming in means getting closer and that zooming out means getting further away. While this is true, it misses something very important, the concept of perspective and how focal length affects that. So we're going to look into this in a lot more detail. So these series of shots are taken from a hill, and I'm going to show you what you normally see. Okay, so this is done with an 18mm relative. So on a full frame camera, which would be the equivalent of an 11mm on a DX or a APS-C sensor body. That's what you would see. And as you zoom in, you apparently get closer and closer to what's on the other side of the lake. Now this is what most people see. This is the thing that most people pay attention to. Well, of course it's getting bigger and bigger because that's what we're doing. Same idea here. This is starting with a 28mm on a full frame, and as we zoom in we get what we would expect. We start to magnify the subject and it gets bigger and bigger. So that's what people normally see. But what I want to point out to you is that in photography there's this thing called perspective. And perspective is the rate at which parallel lines seem to converge as their distance from the viewer increases. Now you can see on the left hand side there, there is a shot of a pathway between two buildings, nicely colored and everything. And the sidewalk appears wider at the nearer towards you than it does further away. Now there's a reason for that. That's perspective. As things get further away, they get smaller. The difference is that a telephoto lens causes something called compression, and the distance doesn't seem to be doesn't pass as fast. The normal lens makes it look the way it appears to your eye, and the wide-angle lens makes it look like it's increasing at a much faster rate. So this is a normal lens on a full-frame camera. It gives what we call a normal perspective. Okay, so it means that parallel lines converge at the same rate as how you normally see. In other words, foreground and background components of the shot are relatively the same size to each other as you would see with your naked eyes. This is why we use the word normal. Okay, so this is a photograph of a image taken with a normal lens. That's kind of the way it looks to your naked eye. Okay, nothing too strange there. A telephoto lens causes compression. A telephoto lens is one that has a focal length more than your normal lens. And when I say normal, I mean relative to the normal eye. That would be 50mm full frame, so longer than that. It causes an effect known as compression. Telephotos cause backgrounds to appear larger than they would when viewed by the naked eye or through a normal lens. This makes them appear as if they were brought closer to the foreground, in effect compressing the scene. The longer the lens, the greater the effect of compression. So this is a photograph I took of Vancouver, and that's Mount Baker in the background. And I can assure you there's no mountains that close to Vancouver, certainly not from that direction. A wide-angle lens causes distortion. Okay, a wide-angle lens has a focal length less than 50mm on a full-frame camera. This means that parallel lines converge at a slower rate than what you would normally see. In other words, the background appears smaller than it normally would when viewed with the naked eye. The wider the angle, or the lower the focal length, this increases the distortion effect. So you can see here on the left that there's a great deal of distortion, and on the right it doesn't appear like there's that much distortion going on, but I can assure you that those boulders are not the same size as the waterfall. So a normal lens, this is the way you would see with your normal eye. A wide-angle lens is going to increase that rate of perspective, and so things that are close are going to be one size, things that are further away are going to get smaller a lot faster. Telephoto lenses, it causes compression, and you can see here that the cows at the back are relatively large compared to the cows in the front. So with a wide-angle lens we have distortion, with a telephoto lens we have compression. So here's all three of these compared. Okay. Now, This is another group of shots. This is with a normal lens. This is with a wide angle lens. Notice how the house looks a lot smaller than the first one. This is with a telephoto lens. Notice how the house looks like it's brought a lot closer than it really is. These are all shots showing the same idea. Okay, this is a telephoto. This is a wide angle. Now, what's important about this is to realize that those background trees are the same as the background trees here. And that bench you see in the front is the exact same bench as that one in the front as well. They're the same bench. Hasn't moved. Okay. Same idea here. Bridge. Bridge with a wide angle. Cat. Cat with a wide angle. Cow. Cow with a wide angle. A series of guitars. Okay, these are actually little guys. They're only about 3 or 4 inches high. And then compressed. It looks like they're really close together. They haven't moved. Another example. Okay, this is a wide angle. This is a telephoto. That mound you see in the back is the same mound that's there. Okay, same exact mound. Truck and the mining museum. Now we can make the truck look a lot bigger relative to the mining museum than it is. This one is done with a wide angle. This one's done with a telephoto. Here's another series of shots. This is Mount Baker again, but shot from the US side. And you can see that we can make the mountain look larger by using a telephoto lens. This is another series of shots, same idea. Okay. Thanks so much for watching. I hope you enjoyed that and hope you learned something. Feel free to email me or take a look at my website. And thanks again for watching.